Okay, let's take a look at number 5 on the practice final. So it's an optimization question, and it's a geometric question. We have, let me draw some axes. So here's a y-axis and here's an x-axis. And let's put a little dot here at the point 3, 5. Okay, so here is 3, 5, and it's talking about lines through the first quadrant that go through this point. So, there's several of those. Like this is one such line, right? And then draw a whole bunch of them, so there are infinitely many. And so what we're interested in is the equation of the line that goes through this point 3, 5 that cuts out the least area from the first quadrant, where they're talking about this area, right? So this area under the triangle. So lots of ways to do this problem. Let's just come up with an equation for, okay, so we'll come up with an equation for the base of this triangle in terms of something, and we'll come up with an equation for the height of the triangle in terms of something, and then we'll just write area equals 1/2 base times height, and then we'll minimize that. Right? Area equals 1/2 base times height. So once we can write area in terms of just one variable, we will just use our calculus techniques to find the value of that variable that makes a as small as possible. Alright, so how should we do this? So there are really two approaches. One of them uses this angle and some trig, and I don't think you'll like that one very much because some people probably their trig is a little rusty. So let's just do it like this. Let's think about this line for a second. It's through the point 3, 5, and we know the point slope form of a line, right? What do lines through 3, 5 look like? They look like y minus 5 is equal to m times x minus 3. So the only difference between them is the slope, right? You can kind of see that. So what's the difference between these lines through this point? The only difference between them is the slope. Alright, well anyway, the slope determines a unique line through this point. So let me rewrite this like this. I have y equals mx minus 3m plus 5. Let's think of it like this. And alright, so now in terms of this, let's see if I can come up with an equation for the base and the height like I was saying. So what is the base going to be? So the base is hard. Let's do the height first. So the height here, this h, is just going to be the y-intercept of this line. And so how do I find that? I plug in 0 for x, and so h is just going to be negative 3m plus 5. Okay, great. And whoa, what causes these things to happen? I don't know. So now we need, okay. So now we need the base. And so how do I find the base? Well, I need to solve the equation 0 equals mx minus 3m plus 5. And what do I need to solve it for? I need to solve it for x. Okay, so it's saying what x coordinate do I put into this thing to make 0 come out? It's going to be, I'm going to get x in terms of m here. So let's do it. So I've got mx is equal to, let's move this stuff over, 3m minus 5, move the 5 over, and so x is equal to 3m minus 5 over m. Okay, and that is going to be this base. So now I just have to write down the area, right? So the area, like we said before, is 1/2 base times height. So I'll just write down the base formula right there. And what did we come up with the height formula? The height formula was negative 3m plus 5. Okay, great. So here we go. Maybe we should, I don't know. We have to take the derivative, right? So I was thinking about putting it together before taking the derivative, but let's just go. Like Charlie Sheen, I've only got one speed, go. So let's use the product rule. This first part Okay, so let's consider this f in the product rule and take the derivative of this thing. So for this sub part, it's a quotient, so I'm going to use the quotient. I'm minimizing it with respect to m, right? Sorry. So now I'm going to take the derivative of this first part using the quotient rule. So the derivative of the top is 3, leave the bottom alone, take away, leave the top alone. And now take the derivative of the bottom, which is 1. This is all over m squared. And so the second part in the product stays the same. And now I say plus, and now I leave the first part alone, 3m minus 5 over m. And I take the derivative of the second part, which is just negative 3. Okay, super fantastic. Now, let's clean up all this junk. We have to set it equal to 0 and solve, right? This 1/2 isn't going to matter. Multiply both sides by 2. And, okay. So what have we got? We've got 3m minus 3m plus 5 over m squared for this first thing here. Okay, and we're multiplying that by negative 3m plus 5. And what's happening over here, let's call this minus 3 times 3m minus 5 over m. And we want to solve this equals 0. So what we need to do is get all this stuff over here over a common denominator, and then we'll just solve the numerator equals 0. We've got this kind of little nice thing happening here. These are the same. So those go away. I also have I kind of have a 3m minus 5 in common. Do you see what I mean? Here's negative 3m plus 5, and here is the opposite. So what I could do is I could change this to a plus and then reverse the order of subtraction. Maybe I'll do that. Okay, so let's do 5 times, let's rewrite this thing as 5 minus 3m. Okay, so this is all over m squared. And what have I got here? I'm going to change that to a plus 3 and then reverse this order. It becomes 5 minus 3m over m. Okay, and now I have a lot in common between these two things, so I can factor out. There's a 5 minus 3m over m is in common to both. So what happens after I take that out? 5 minus 3m over m, and now I have 5 over m left here, and I just have 3 left here, plus 3 equals 0. Alright, so let me put this stuff in here over a common denominator. I've got 5 minus 3m over m, and on the inside here this is 5 plus 3m over m equals 0, and so put all this stuff together, and finally we have 5 minus 3m times 5 plus 3m over m squared equals 0. So now we can read off the solutions. Okay, so we've got the numerator is going to tell us the values of m that make this true, so we just have to look at these two parts separately. So what does this part say? This part says that one solution is m equals 5 over 3. Okay, so you can just see if you plug that in, then the 3's cancel and you get 5, and 5 minus 5 is 0, so that works there. That's probably not going to be a very good answer, because look at the picture. What happens when m has a positive slope? It's like a nightmare, right? It's not cutting off any area at all from the first quadrant. So I think we can ignore that one. And now let's look at the solution for this other part. Okay, so what works there, it's going to be m equals minus 5 over 3, right? So now the 3's are going to cancel, and I'm going to have left minus 5. And so I like the looks of this one, so this must be it, right? So the extreme value must be at a critical point. This is the only critical point that makes sense, so this must be the answer. And I'm really done, right? Because I had this, what is the question asking us for? It's asking us for an equation of a line, and I already knew everything about the line except for what m was. So I'll just take this. I know that m is equal to minus 5 over 3. And so now I'll just plug that in. So the answer to the whole problem is y equals minus 5/3 x minus 5. Okay, so that's what happens here. The 3 and the 3 cancel, the negative sign cancel, it's plus 5 actually. Here's another plus 5. So the final answer to the whole thing is minus 5/3 x plus 10. Okay, great.